Hi, let's try another problem of solving the system by graphing. Now I have this equation y equal to x plus 2. That's my first linear equation. I have the second equation y equal to 3x minus 2. Both together form the system. So I want to graph them and figure out my solution. As we know, these equations are given to me in slope-intercept form. So this is the easiest one to graph. So the first point I'm going to graph my first equation first. So in this equation, my y-intercept is 2 and my slope is 1. The coefficient is 1, so the slope is 1. So I'm going to graph that. The first point I'm going to put is my y-intercept, which is 2. And my slope is 1. Just rise over run. So 1 over 1, so up 1 and over 1, I got my second point. All I need is 2 points to graph my line. I can keep on going to find more points, but all I need is 2 points. So I got my line. I use a straight edge to draw my line. That's my first line. My second equation is y equal to 3x minus 2, again given to me in slope-intercept form. My y-intercept is negative 2. So that's the first point I put on my graph. And my slope is 3, which is 3 over 1. So my rise is 3, 1, 2, 3, and run is 1. I got my second point. So I graph my line using a straight edge. Gotta be precise. My intersection point is 2, 4. So that's my common point to both lines. So my solution is 2, 4, but I still need to verify if that's correct. So I'm going to plug into my equations and check if it is correct. So my first equation is y equal to 1x plus 2. So if I plug in 2, 4, so y is 4, x is 1, x is 2. So together it gives me a 4. It checks. So the second equation is y equal to 3x minus 2. Again, I'm going to plug in 2, 4 for x and y. So y is 4, x is 2. It still works. And it works for both equations. So my solution 2, 4 is correct. So now let's consider these two equations. So you could be given any combination, standard form, slope-intercept form, or it could be anything. So you can change it to standard form or slope-intercept form and then graph it. So here I'm given these two equations. The first equation is in standard form. The second equation is in slope-intercept form. So the first equation, I'm going to find my x and y intercepts. My x-intercept is x, 0. That means when my y is 0, what's the value of x? So y is 0, so 2y goes away. I have negative x is 2, so positive x will be negative 2. So my x-intercept is negative 2, 0. My y-intercept is the point 0, y. When x is 0, 2y is 2, so y will be 1. So my y-intercept is 0, 1. So my points are negative 2, 0 and 0, 1. So my first line is that. My second line is given to me in slope-intercept form. My intercept is 0, 1. So I got my point right there. And my slope is 1 over 2, rise over run. So rise is 1, run is 2. So I got my second point. So when I draw the line, I'm finding that I'm getting exactly the same line. Yeah. So what happened there? So when I look at this equation, this is given to me in slope-intercept form. When I try to rewrite this, 2y minus x equal to 2. If I rewrite it into slope-intercept form, that means I'm getting my y all by itself. So plus x. So 2y is equal to x plus 2, or it is 1x plus 2. Then I have to divide by 2. So I got y equal to half x plus 1. So if I compare my equation 1, which I rewrote in slope-intercept form, with equation number 2, they are identical to each other. They are one and the same. That's why I got the same line. Alright, so when I look at this, so as we said, the solution to my system is the common points to both lines. So when I look at it, line number 1 and line number 2 both are exactly the same line. And the common points are all the points on that line. They are all the points on that line. So the solution to the system, I have many solutions. Solution to the system are many. Okay, so I say infinitely many solutions. Okay, so this is a special system, meaning I have both lines that are one and the same. Even though the equations look different, they are equivalent to each other. They are equivalent equations. So that's why I got the same line. So this is one type. You could face this situation. When you are given two equations, you will be facing such situation when you graph. You might end up with the same line. So if it is the same line, that means there are more than one point that is common to both lines because they are one and the same. They intersect each other at all the points on the line. So the solution to the system will be many. So I call them infinitely many solutions. So let's take a look at this one. I have these two lines given to me. They form a system. So I want to graph this system and figure out my solution. So as we see, both are given to me in slope-intercept form. It's very easy to graph them. The first one, it's 2x plus 2. The y-intercept is 2 and the slope is 2 over 1. Okay, so the first one I'm going to put is my y-intercept, which is positive 2. And my slope is 2 over 1. The rise is 2, run is 1. Rise is 2, run is 1. So I got my first line. On the graph. So let's go ahead and graph the second one. This is also in slope-intercept form. My intercept is -1 and the slope is again 2. So the first one I'm going to put is -1. Slope is 2. So 2 over 1. I got my second point. I got my second line. As you can clearly see, these two lines are parallel to each other. They are slanted the same way. That means they have the same slope. You can verify that in the equation. The slope for this equation is 2. The slope here is also 2. So parallel lines, they have the same slope, but different y-intercept. When I look at the equations, the y-intercept is 2. The y-intercept here is -1. So these two lines are parallel to each other. Will they ever intersect? No, they won't intersect anywhere. That means there won't be any common points between these two lines. So that means there is no solution. No solution to this system of equations. There is no common point. There is no common point. You will face such a situation also. Okay, so when you are given two equations, they might end up to be parallel lines, so they will never meet. So that means there is no solution, there is no coordinate on the graph that will satisfy both equations. meaning there is no common point between the two equations. So that makes it a no solution system. All right. So based on these three types, what do I mean by these three types? The first equation, where my two lines intersected at exactly one point, and my second type, where my two lines intersected at all points. They are all common between them. And the third type, where my lines never intersect. They don't have any common points between them. So based on these three types, I can classify my system of linear equations. So now comes classification. Classification of system of linear equations. Okay, classifying means what type of system is it. Okay, so if a system has a solution, there are two types of system I have. One is a consistent system and the other one is an inconsistent system. Inconsistent system meaning it has no solution. Consistent means it has solution. It could be one or it could be many. So based on this, a system can be classified into two broad categories. One is a consistent system, the other one is an inconsistent system. The consistent system in turn can be classified into two types. One is system with one solution. System with one solution. And system with many solutions. System with many solutions. I call it an independent system. So when I say, I should say consistent and independent. If there is a system with one solution, this is a dependent system. Dependent system. Okay. So when I have one solution, if the system has one solution, that is, it intersects exactly at one point, I call it a consistent and independent system. Consistent and independent system. If the system has many solutions, I call it consistent and dependent system. If it has no solution, I call it inconsistent system. So I'm classifying the system based on the number of solutions it has. If I have to draw a picture for each one of them, let's number them 1, 2, 1, 3. For 1, I'm looking at a graph, something like this, where they intersect exactly at one point. The slopes of the line are different. Slopes of the line are different. If I have to draw a line for many solutions, this is many solutions. I'm looking at a graph. The lines are one and the same. Coincident lines. Coincident lines. Same slope. Same y-intercept. If I look at the no solution system, they are parallel lines. They are parallel lines. Same slope. Different y-intercept.